In this problem, we're opening up a 401k. We're going to do a couple of things. Number one, we get a recent bonus, and we're going to take that bonus and we're going to initially deposit that into this 401k. So basically to get the money rolling. We're going to make regular deposits of $150 per month, 7.88% compounded monthly. The first question is, what will you be able to accumulate in 20 years? So since this is compounded monthly, I'm going to draw my time diagram real quick. And 20 years, if you don't know it in your head, you can always type it in here. Times 12 is going to be 240 months. So 240 months is going to be the length of the investment. We're going to put away $150 a month. Payment equals negative 150. And initially, we're also going to have an outflow, a single out-of-pocket outflow, or present value of negative 1,000. So this has to be negative, and this has to be negative because these are both the items that are coming out of our pocket. Then at the end of this term, we're going to get something out here. Keep in mind 7.88% compounded monthly. And so now we can enter our information. So we have 7.88% compounded monthly. Present value is negative 1,000 because we're putting in a $1,000 bonus. Payment is the regular $150 monthly payment. Future value is what we're going to calculate. We just need to make sure our compounding periods are okay, which is it's monthly, so this is good. And that means that at the end of 20 years, we'll have $91,857.77. Now that is not very much. That may seem like a lot at first, but think about what a person makes on average in a salary. At least 30 or so thousand probably by the time they retire. So if this is a retirement plan, this is not very much to live off. So we want to ask some more questions about it. In part B, well, first of all, how much interest will be accumulated during the last year? Okay, well that requires a couple of pieces of information in terms of knowledge. Number one, we need to know how much what the balance was coming into the last year. And number two, we need to know what the total balance was at the end of the term. Alternatively, we could go ahead and use our calculator tools. We'll do it both ways. In the finance, down below, recall that we need to select the sum of interest, payments, and now we need to specify the months between which we want to know the total interest. Okay, well, what's the last year? The last year goes all the way up to 240 months. Subtracting away 12 would actually put us at 228 months. So here's 228 months. However, keep in mind that we're counting the very last month as well. So we want to go from 229 to 240. That's 229, that's 1, 230 is 2, and then 10 more to get us to 240. So be kind of careful how you use this. We want to go 229, comma 240. That should give us the total interest earned over the last year. And that amount is $6,864.14. So be careful not to just put in year 20 because this is in terms of months, and that's how your calculator is thinking. And so we did sum int month 229 to month 240. Once again, the 229 is used because we're counting 240, 239, 238, 237, 236, etc., and including 229. And if we wanted to do this by hand, what we could figure out is, well, what's our balance after the 228 months? So after 228 months, we could figure out what our future value would be. Okay, this is after 228 months. So after 228 months, or coming into the 229th, we would have a balance of $83,193 and 63 cents. After 240, we know that we have a balance of $91,857.77. Now that's a difference of, the difference between those is going to be 91,857.77 minus 83,193.63, and that's $8,664.14. And you may say, well, hey, wait a minute, that doesn't match up with what we got up here by using the calculator function. Keep in mind that going from this balance to this balance is not pure interest. There were $1,250 monthly payments made month 229, month 230, month 231, month 232. So we need to subtract away also the $1,250 payments that were made so that we get pure interest instead of this, which includes interest and principal. So we do 8664.14 minus $1,250 payments, and that gives us, notice, 6864.14. So these are just two ways we could do it. Some people just like to know how to do it by hand, and it's not really tricky. It's just takes a little bit more caution, and sometimes we don't have the calculator handy. So this is a way we could do it. Find the balances at 2 periods of time, figure out how much out of pocket went in during that period, and then subtract away that from the difference in the balances. Still got a little bit to keep going here. Letter C is how much larger would your payment need to be in order to reach a goal of $1 million by retirement? So we just need to figure out, and we're still assuming that we're going to make the lump sum deposit of $1,000. Okay, so we're going to come over here. Got to change this back to 240 months. Oh, how much longer? So we need to actually, how much larger would your payment need to be in order to reach a goal of $1 million by retirement? Okay, so 240 months is retirement, 7.88% compounded monthly, $1,000 initial deposit, $150 monthly deposit, and we want to know, okay, in order to accomplish a goal of $1 million, that's what we want as an outflow, well, how much larger would your payment have to be? So we want to calculate what this payment would be in order to have an initial deposit of $1,000, make regular payments, and earn $1 million. So your payment would actually need to be substantially larger. It would need to be $1,714.92. So really a big difference there. So in letter C, we would need $1,714.92 per month. Letter D, letter D, suppose you are set on making the $150 monthly payment along with your initial $1,000 lump sum deposit. Okay, so we're going to come back here. We're going to say, all right, we're set on making the $150 payment now in letter D, along with the $1,000 initial deposit. And we want to know, what would your interest rate need to be to accomplish that $1 million goal at retirement? So something's got to give, right? We still want to have the same term. We still want to have the same payment, the same present value, the same future value. So something's got to give. The only thing that can change is the interest rate. And the interest rate is something we can calculate. So the interest rate would need to be a whopping 24.1, we'll say 15%, because there's a 1.14 and a little bit more. So we would need, to the 100th place, about 24.15% APR. That means this percent compounded monthly in order to be able to accomplish this goal. So this is totally unfeasible unless you get some great new like Google type stock where it just sort of streams in money. So this may be an unrealistic goal. In letter E, keeping the original rate, how much longer would you need to make $150 payments in order to accomplish your goal of $1 million? So we're assuming now, okay, well, we're seeing it's unfeasible. So in letter E, we want to know, what would the interest rate, what would the time need to be in order to keep making the same payment? So we're still going to do 7.88%, $1,000, $150 monthly payment, $1 million. The only thing that we're willing to sacrifice is, okay, well, how much longer would I need to work for in order to reach my retirement goal of $1 million? And the answer is about 575 months total. Need 575 months until retirement. So what does that amount to in years? Well, in years, 575 divided by 12 months per year is about 48 years in order to be able to accomplish this goal. So the point being, start early and invest as long as you possibly can before you retire.